Hi everyone, welcome in another session of AI/ML. Today we will be going ahead with ethics in AI and explainability in AI. We will go ahead and understand each of them in details. Let me just share my screen and let's start with this. Yeah. Hopefully my screen is all visible to you people. So first we will be understanding about ethics in AI. Okay. Okay, let me just a moment. Yeah, fine. So ethics in AI, basically, what is ethics in AI? So ethics is knowing what is right and what is wrong. Okay, so what is ethics? It's right and knowing what is right and what is wrong. Okay, so this is all about ethics. Basically, some example if I need to give you, like among students or among any of the people, what is the most common thing? Like sharing toys, that is a good practice, right? So let's just have some of the idea about, take some of the example relatively, and let's just discuss the things right way. Okay, so here we will be taking care about some of the examples. The very first one is sharing toys. Okay. Next is right cheating in exam. Right. So sharing toy is of course a good practice, right? Sharing, we always try to make sure that we share the items or share any of the things that we are using. Coming down cheating in exam, that is not a good practice. So that is a bad practice. Coming down about being fair. Being fair means in the sense like whenever whatever you are doing, you are just staying fair. Okay, just staying fair, like there is no discrimination, nothing is happening, that nothing you are doing whenever you are working on something, right? So that is being fair, so that is a good practice, right? Next, about hurting others. So that is a bad practice, right? So this is the thing. So ethics is basically knowing what is right and what is wrong. So sharing toy is a good practice. So this is the right work. Cheating an exam, that is a bad practice and that shouldn't be done. So that is a wrong practice. Coming down, being fair in whatever games you are playing, being fair in whatever food you are preparing, being fair to in each and everything is a good practice, right? So that is a good ethics that you can count it out. Now, what is AI? AI, all you know, it is a artificial intelligence. So AI is a computer brain, you can say, that can learn, decide, predict, help human in their day-to-day tasks. Okay, some of the examples related to AI come down as face recognition, recommendation, chatbots, self-driven cars. All of this come in that. Okay, so what is this ethics in AI? What is ethics in AI? Okay, so that is basically teaching AI to behave nicely, safely, and fairly. What it is? It's like teaching AI to behave nicely, safely, and fairly. Okay, so that is ethics in AI. Just like the parents actually teach the children to behave good, teacher teach the rules. So human must teach AI some of the good rules that it should follow, because AI is just like just like a student, right? Just like the student. So we have to take it up accordingly. What instruction we will be giving to AI, AI will be performing that. So there should be a control. There should be a control. So the humans who is generating this artificial intelligence, they must teach good rules to AI, right? So why do we need ethics in AI? Right? Suppose you imagine that you teach a robot how to play cricket, but you don't teach the rules, right? Then what will happen? The robot will cheat, robot will hurt the players, robot play unfairly. So the same thing comes down with AI. So AI is powerful. So wrong AI is actually a dangerous one, right? So ethical AI actually is a helpful friend we can call off. So we want to take it in that way so that AI can be a helpful friend to each one of it, not a dangerous one. Okay. Now coming down with the big problem if AI has no ethics. Okay, if AI has no ethics, then the very first problem that we will be faced that is bias, that is unfairness. Okay, that is unfairness. So bias, what is bias? Bias is like being unfair to someone. Okay, being unfair to someone. Okay, now coming down with the example. Let's think about teacher always give more marks to one student. Okay, referee favors one team. This is coming out as an example of biasness. Okay, now coming down to bias in AI. So what happens? AI selects students for scholarships. It was trained using data for only boys. In that case, what would be the result? AI only select the boys, it will ignore the girls. So this is an unfair practice, right? So we want our AI system that is going for any of the job, do the job like fairly. There shouldn't be any unfairness that will go. Okay. So basically here how the thing is going, like the example I have given, like I want to go for a selection for the scholarship among the students. So AI will select the students for scholarship. Okay. So what is the criteria of getting scholarship? The criteria of getting scholarship is like getting good marks in the exams, having the proper, like if there is any entrance, you have to get a specific marks out there. Based on that, your selection for the scholarship has been done, right? So in that case, if my AI model is being trained using the data of only boys, if the AI model is trained using the data of only boys, in that case, what happened? In that case, the AI will select the boys only. Okay. And it will ignore the girls. That means the girls won't be getting the scholarship for this, but the boys will. Okay. Let me just put it up. Yeah. Okay. So now this what is this practice? This is an unfair practice. This is an unfair practice. Okay, where it is? Okay. So this is an unfair practice. This is unfair. So we want to ignore this. We have to make it that way that we have to make the AI model that way that there is no unfair event that is going. So here basically how it is going, like how we are doing it, we are training the data. There should be like if we are just going for the unfair practice, there is 80 boys and 20 girls. That is the most winners are coming down from the boys, That is the reason we are getting the scholarships are been given only to boys. Okay, so most scholarship will be provided to boys. Okay, so now basically here, so we have got the probability here. So the probability for boys getting the chance is around 80% and about girls getting the chance is around 20%. So that is an unfair event that needs to be taken. So here AI is copying the bad data, not thinking about it, right? So here the important rule, AI is not bad. Bad data makes AI bad. So we need to maintain the data that we are feeding to the AI. So there should be equal contribution for boys and girls. So for boys, there should be 50% of the data for boys, and along with that, girls' data should be also 50% to make it fair. To make it fair. Okay. So, of course, here, the important thing that we need to understand here, of course, AI always is not bad. AI is not bad. What is bad? The data makes, like, bad data makes AI bad. Okay. So we need to make sure that how we are feeding the data and in what way we are feeding the data. Is the data that we are feeding to AI, is it actually doing good or not? That we need to have an idea over. Okay. Coming down to the second point, that is privacy. Okay. So privacy, what is privacy? Privacy means your secrets stays yours only. No one reads your secrets. Okay. It's like you have a secret diary and no one is allowed to read your diary. Okay. No one sees your message without your permission. That is privacy. So AI can create your photos, can tag down your location, your messages. If misused, then AI actually spies, AI leaks the data, and AI breaks the trust. So, so that is the reason we need to make the AI accordingly well. Okay. So suppose we have the example. Suppose face recognition. We all use face recognition in our phone, right? So face recognition AI. Okay. So face recognition AI we are getting that is good when when unlocking the phone, right? Unlocking the phone. Coming down bad when track people without permission. Okay, so that is the problem. So now coming down the ethical rule related to privacy. Ethical rule comes down as AI should ask, do I really need this data? Did the user give permission? This type of question the AI should ask. If the user has given the permission to AI, of course, AI can use the data. If not given, it should not use the data. Okay, so this is the idea. Okay, coming down to the third point, that is transparency. Okay, transparency, that is honesty. So it should do all of the transparency accordingly. Like transparent means being honest, explaining the decision. For example, the teacher explaining the marks, doctor explains the treatment, right? So what is the problem? Many AI models are the black boxes. Okay, even creators don't know why AI make a decision, right? That is the idea. So, for example, suppose AI says the loan rejected, but there is no explanation, no reason why it is why it is taking this decision. So, what is the solution? What is the ethical solution for it? AI should explain. That is what is like. This is the reason for your loan has been rejected. Maybe your income is low, your credit scores are low. That's why we are taking this update, right? So that explainability needs to be taken. So we have the ground for explaining about explainability. So we'll just take it later. What is explainability? How we can take it, right? So that we will be discussing. The third point goes down to transparency. Coming down to the fourth point, that is accountability. Accountability, that is responsibility. So, what is accountability? Accountability means like taking responsibility, accepting mistakes. So, so if AI makes a mistake, who is responsible for that? Is it AI? Is it the programmer or the company? Right? So that needs to be fixed. So the self-driven car accident, right? So who is responsible? Human must also always be responsible. AI should never escape the blame, right? That should be the correct thing. So AI should not like it shouldn't escape the blame of that it is responsible. So in certain case, the based on the decision that AI is making, some unexpected circumstance can happen. So it should take the responsibility of it. Okay. So that is coming down with the accountability. The fifth one coming down as safety. Okay. So what is safety? Safety means like no danger, no harm. So AI safety problems. There is some of the AI safety problems. So AI, if AI is wrong, suppose medical AI gives wrong treatment or driving AI cause an accident, right? So AI is making like we need to make it harmless or we need to make it away from the danger. So AI must be tested a lot before use, be stopped easily, and have a human control. Okay, because humans are the best ideology that one can give. Like about a doctor. Okay, so AI is doing a good work of just giving the prescriptions and giving the treatment, but there is no alternative of a doctor, right? Of course, coming down to the codes and softwares and stuff, everything. AI knows it, but of course, there is no replacement of a human or a software engineer in case of any tech, right? So we need to make sure that things are placed and there should be a human control everything. Like if there is a medical AI gives a treatment to a patient, there should be a proper doctor who actually checks each and every stuff before handing it over to the patient and the patient without any proper idea like without any proper idea shouldn't go for the medication that has been prescribed by the AI machine, right? So there should be a human intervention up there. There should be a human control. There should be a proper doctor, well educated person who well educated doctor should be there who is just rechecking each and everything, the reports of the patient, the medicines prescribed to the person, everything needs to be cross checked, then only it should be given. Okay, so there should be a human control. Okay, so this is the idea about coming down and some of the ethical AI principles like the golden rules. AI golden rules is like be fair, be safe, respect the privacy, be honest, help humans and do not harm. So these are the AI principle, ethical AI principles. I'll just write it down for you so that you have an idea about it. So that is ethical AI principles. That comes as the very first one is be fair. Second one comes down as be safe. The third one comes down as respect the privacy. fourth one coming down as be honest. Okay. Coming down, we have to just take it like we need to help the humans, like the AI needs to help humans, not to harm, do not harm, and do not harm. And the sixth one is be a friendly, helpful, be a helpful friend to humans. Okay, so these are the ethical AI principles. Okay, now coming down AI versus a human child, there should be a comparison. Okay, so a human child, how the human child learns? Human child learns from the parents. Okay, so the AI also learns from where? Learns from the data that needs to be given. So we need to have a closer look what data we are providing to the model, to the AI system, or what is the data, is there any biasness in the data, is it going unfair, we need to have a proper check. Okay, so of course human child can have other benefit, other stuff as well, like they learn from different people, from the parents, from teachers and all. They need a specific rules, right? And AI actually needs some of the ethics to work accordingly. Of course, AI ethics need a human control. Like the AI actually needs a human control to take it over. Everything can't we can't rely entirely on the AI. There should be a human intervention when some of the tricky or some of the very crucial part has been totally handled by AI. So we there should be a proper human interference up there. Okay, of course, of an expert, of a guided person. Okay. Now, coming down with the use of AI, like coming down with AI systems of face recognition. The ethical risk that can happen for face recognition is privacy. Privacy. Okay. Face recognition, we have the privacy is the ethical risk. Okay. Coming down, we have hiring AI. So that is biased. Coming down to medical AI. So that is related to safety. Okay. Next, we have recommendation AI. So that comes under with addiction. Okay. And chatbot is misinformation. So this is the idea. Now coming down with the future of ethical AI. In future, there should be AI laws that should exist. Okay. So about future of ethical AI. The very first one, they should like the laws that is like AI laws should exist. Okay. Coming down to the second one, there should be a ethical check before the AI launch. Okay. Coming down to the third point, there should be an explainable AI. And the fourth point comes down human in the loop AI. Okay. That is human in the loop AI. That means there should be AI. AI is of course good, but AI is good within human control, within human intervention. That needs to be taken accordingly. Okay. So this is all about ethics in AI. Now we will be discussing about explainability. What is explainability? Okay. So what is explainability that we will be discussing? So what is explainability? First, we need to understand what is explainability. Explainability is the ability to explain the decision. Okay. What is explainability? It is the ability. It is the ability to explain the decision. Okay. Now coming down, if someone asks, why did you do this? Right? There should be a proper explanation. Like, this is the reason I have done this, right? Which human have, but this AI system lacks. So we need to have a explainability in AI. Okay. So explainability in AI means AI should tell us why it gave us this answer. Okay. So that is explainability in AI. Coming down, as I have given you the example of loan rejection. Gets rejected of a person. But why? Loan rejected because the income is low, credit score is poor. That should be a proper idea, right? So we need to have a proper explanation of the task. Now, teacher has given some of the marks. Teacher has given some of the marks. Okay. Coming down, the reason you failed. Somehow you have got the result, you or anyone have failed. A student has failed. Okay. So that is no explanation, just direct answer. That is the student has failed. Okay. So that means that there is no explanation, right? There is, okay, just a minute. There is no explanation. Okay, coming down about the second one, like suppose you are getting that output as you failed because you didn't write the answer clearly. You failed as you didn't write the answer clearly in the exam. Okay, so that is called explainability. So AI should behave like a good teacher, which feels fair, and the second one is it should behave like a good teacher. So that is the that is the idea. Okay. Now, why do we need an explainability? Why do we need an explainability? So why do you need a explainability? That we need to discuss. Okay, before that, let's just okay. Why do we need it? The very first one is the trust. Trust means if AI explains, we trust it, right? So that is the reason we need explainability. So first one is trust. Coming down to the second one, that is fairness. Okay. So we can check if the AI is biased or not. Is it giving the fair idea or not? Right? For that, we are checking. Coming down to the third point is safety. Safety is we can find the mistakes if there is any mistake that we can find it early and we can take it. And it is like safety means if there is any explanation going, so we can check for like what is going wrong and how it is going wrong. That we can find it out. Okay. Coming down to the fourth one, that is learning. Learning, like we prove AI when we knows the error. If that is the idea, so there should be a proper explainability in case of learning also. Okay. Now, what happens without explainability? Okay. Suppose, imagine there is a black box. The input goes in, the output comes out. There is no idea what happened inside. That is called a black box AI. Okay. Now, the example about deep neural learning, deep neural networks, then large language models. That what happens inside, like in case of the hidden layer, in a case of neural network, what happens? We don't have the idea, right? So that is the reason we need an explainability. Okay. So there are different types of explainability. Now we will be discussing about the explainability type. So the very first one is global explainability. The second one come down as local explainability. Coming down, these two are the types of explainability. Global explainability means how AI works in general. It explains how AI works in general. Okay, so that means like suppose this AI model looks the marks as 70% and attendance about 30%. So this kind of idea we are getting. Okay, so suppose we are just checking for the student getting like passed or not. So that depends on the marks of 70% and attendance of 30%. So this is the explainability that AI model is giving, right? So that is the idea. Coming down to the local explainability, like why this decision was taken. That comes down as local explainability. Like, suppose your marks are low, so you got rejected. So that is a decision. The decision was rejected, but why it is rejected? Because your marks were low. Okay, so that comes down as local explainability. Okay, now let's have a discussion about a linear model. Let's just take an idea about a linear model. Okay, we have taken a linear model. Okay. Now, basically, how it is going, we have the score. So that is going supposed to into marks plus 1 into attendance. That we are going. Suppose if marks is 40 and we are getting attendance as 30. So how it will be getting the score? So we will be getting 2 into 40 plus 1 into 30. Right? So we will be getting 110, right? So this is so simple, right? Easily we have explained this. Like this is the formula, and since marks is 40, attendance is 30, we are going like that. This is easy to explain, right? Now, any of the complex AI model that has less explainability, like deep neural network, thousands of neurons are there, millions of calculation are happening, hard to explain, right? But needs a special tool in that case that will explain the idea. Okay, so for that we have some of the explainability tools. Okay, the very first one is feature importance. So, which input matters the most? That idea we are getting up here. Suppose we have the marks that is coming out as suppose 60% importance. Next, we have attendance That is coming up around suppose 25%. Okay. Now coming down about sports. So that is coming out around 15%. Right. So that is the idea. Now coming down to the second point, that is if then rule. If then rule. That is basically if the marks like the thresholding, right? If marks are going smaller than 50, we will be that would be reject. Now suppose if marks greater than 70, that is accept. Okay, so that is the idea. Now there is visual explanation. Visual explanation. So that is for images like heat map, highlighting the important areas. So AI highlights the face in the image recognition, right? So that is an example of a visual explanation. Okay. So that is the entire idea. Now we need to find out about, like, as you all know, we have the weights, that is the importance, that shows the importance, right? So that we use in case of deep neural network. Like we have suppose marks and the attendance, right? So here you can see it is 60% and 25%. So if I had to put the weight, I'll give the weight as suppose 3, and for attendance, I'll take the weight as 1, right? So that is the idea. So what is now explainability here? So if the marks increase by 10, the score will increase by suppose 30, right? So that is the explainability that we can just discuss up here. Okay. So now we have some of the explaining, we have to explain some of the black box model. The two black box model that we will be explaining, one is shape, another is light. Okay. SHAP, basically, we call it SHAP and we call it line. Okay, so we will discuss everything in details about SHAP and Lime. Okay, so what are this? SHAP and Lime both are the black box AI models that we are using basically for explainability. Okay, so in simple way, Lime actually changes the input a little, sees the output change and guesses what matters. It's like poking the AI to see the reaction, and coming down with Sharp, that is each feature is the player for it, and all players contribute in the final score. So who contributed how much, that Sharp actually find it out. Okay. So we'll discuss everything in details. Don't worry on it. Coming down about Sharp. So what is the Sharp in details? So Sharp is like a method to explain AI decisions fairly. It's a method to explain AI decisions fairly. Okay, coming down to Lime. What is Lime? Lime here. So first let's discuss about Sharp, then we will be discussing about Lime. Okay, so that would make it better. Okay, now what happens is the like we have to suppose answer some of the questions. Why did AI give this answer? Right? So, what is even better? Which input helped how much? This is a better question. So, we'll get a probability how we are getting it around there. So, for that, SHAP is responsible. Okay. Now coming down, we have we'll just take an understanding, and based on that, we will be following each and everything. Okay. Suppose we are just going and asking like shaping the part we are going for shaping. Okay. Now suppose we have suppose the four friends studying together. Okay. Now we have suppose four friends. We are naming that them as Rahul, Aditi, Next we have Aman. Next we have Neha. Okay, these are the four. So they scored 100 marks together. So together they have scored 100 marks. Okay. Now, suppose the teacher is asking who contributed how much. So you can't just guess. You need a fair method of finding who has contributed how much. So SHAP is that powerful, fair method to calculate the contribution of each of the students. Okay. So that is the idea. Okay. Now, why do we need SHAP in AI? That is a major question. So, AI models, especially deep learning, are the black boxes. Give the answer without the explanation, like loan rejected, right? So, suppose I have got the example of loan rejection. If we are using, SHAP, so we'll get the contribution. Okay. So, SHAP will explain like that. Suppose income, the contribution of income comes down as suppose minus 40, the score that I'll be getting. Suppose we have the sorry, credit is going out as suppose minus 30, that is the score. Age is going as plus 10, and total, that is going as minus 60. Okay. Minus 60. So the now this decision, like if loan rejected, this is the explanation, right? Now the decision actually makes a sense because the income was low, the credit score was low, the age is fine, but in total we are getting the score as minus 60. Okay, so that is the reason we that actually makes a sense up here. Okay, so Shap asks if I remove suppose one input, how much does the answer changes? That change is coming down as the contribution. Okay, suppose if I just remove this age as plus 10, so my total value will be coming down as minus 70, right? So that is the basic idea of SHAP. Like if any of the input has been removed, so how much does the answer will be changing? So what is the different answer? What is the difference between the old answer and the new answer? That is the idea. Okay, so this change is basically the contribution. Okay, now let's have an idea of pizza. Okay, so a pizza with the ingredients. Okay, so we have the pizza. So that is suppose we are giving it 100. Okay. Now we are calling about ingredients. So suppose ingredients we call it as onion or we call it as cheese. We give it sauce like that. Okay. Here let's put it as toppings. That is better. Okay. Now basically why like we are trying different combinations. Like what makes the people happy, what makes the people happy, with what ingredients people get more happier if that thing are there inside their pizza. Okay, so now we are calling ingredients with the happiness. Okay, suppose there is no ingredients, none, so the happiness goes thus to zero. Okay, now coming down to cheese. So it's count at out 40. Okay. Now we have sauce. Then it is 30. Next we have suppose toppings. So that is 20. Okay. And we have all, then it is 100. Okay. So chef fairly distributes cheese to 40, sauce to 30, toppings to 20, like that, so that everyone gets a fair credit. Okay. Everyone gets a fair credit like that. Okay. So this is all about SHAP. Okay. So SHAP is basically like a linear model. Like if the model is linear, SHAP works very easily. If that is a tree model, SHAP works very fast. If that is a neural network, it works slower, but it works. Okay. And about black box, yes, it does work. So SHAP works almost everywhere. Okay. So this is the idea about SHAP. So SHAP is like average contributor. It's like the average contribution of the feature across all of the possible feature combinations. Okay, that is what SHAP is finding it out. Okay, so SHAP is used in banking domain, in medical AI, in hiring AI, in insurance, in government AI. Banking, it actually helps about explaining the loan decision. In medical AI, explaining the diagnosis. About hiring AI checks the biasness, and insurance explains the pricing. About government AI, it goes for the transparency. If AI decisions, AI must explain it. If AI explains, SHAP actually helps in giving that idea. So SHAP is equal, we can think about like fair explanation tool. It tells actually who helped, how much, and why. Okay. So this is all about SHAP. Coming down to Lime. Lime is a tool that explains why and an AI made one specific decision. Okay. A tool that explains why an AI make one specific decision. This is Lime. Okay. Now Lime as a like you can think about Lime as a teacher. Suppose you have got 6 out of 10. Okay. Now you ask why. Okay. So what happens in that case? The teacher explains like the paper accurately. Suppose the question one, you have made a mistake. Okay. So you made a mistake in question one. Coming down to question two, you also made a mistake in question two. Okay. But other question was correct. Other question was correct. Okay, so that is what Lime does. Okay, why do we need Lime? Because AI models are very smart, very confusing, and black boxes, right? So Lime open the box for one decision, explain it in simple human rule so that things can be easily taken. Okay, so Lime works in three specific steps. So the step one is it looks at one data point, looks at one data point. Coming down to second point, so it makes all small changes. And the third point comes down, learns a simple model around it. Okay. So here, if I need to give a real life example, so fruit classifier AI. Okay. So this fruit is an apple. Okay. Now this fruit is an apple. This is the output that we have got. The output we have got that it is an apple. Okay. Now you ask why. So Lime, what it checks? Lime checks color, coming down to the shape and the size. Okay. So if the color was like red, if the shape is round, if the size is like bigger, So that kind of idea we are getting. It checks for it. Now, what is the output we will be getting? So line says, suppose red color that is coming around 40%. Next, we have round shape that we are getting 35%. About small size that we are getting around 10%. Okay. So this is how Lime exactly works. Okay. This is how Lime exactly works. So it picks one prediction. Okay. So that it works at locally. It works at locally. Okay. So Lime does not explain the whole AI. It explains a specific decision. Okay. So this decision only. Suppose we have got the email. Email is spam. So why it is spam? That idea we will be getting. As we have given the idea, like it looks at one data point, like it picks one prediction and goes accordingly. It explains that why it is that. It creates a fake neighborhood, like makes a small change. That means it creates a fake neighbor, like it creates a slight change in the output, creates many similar examples so that we can get the example like that, like removing the word anyhow or removing any of the stuff that is related that we are doing. Coming down, it asks the black box for every fake example, like we ask this AI as spam or not spam, and then it train a simple model, like a linear model or a decision rule, and explain in human language. Okay, so that is the idea, that is how it is working. So Lime also gives the weight. So any of the specific weight it gives based on the similar way that we have discussed. So that's why it work as a locally, like it explain one point, not the whole data set, right? So that is how we are just going for Lime. Okay. So this is all about SHAP and Lime. That is the part of explainability in case of AI. Okay. So this is all, guys. We have discussed about this in details, like everything we have discussed about it in details. Like what is ethics in AI, what is explainability in AI. Now coming down, we have also explained about Sharp and Lime. So now about some of the core difference we will also discuss about explanation. Okay. In Lime, we are getting the approximate explanation, but in Sharp, we are getting the exact explanation because in case of Sharp, what happens? We are getting the contribution, each of the contribution accordingly. In case of Sharp, what we are going, we are getting the contribution accordingly. What are the contribution for each of the specific things we are getting. But in case of Lime, we are getting the approximate. Here also we are getting the idea, but not the exact one. About speed, Lime is faster than Sharp, and about maths, in that is required inside the explainability. Lime goes for a simple math, but Sharp go for a deeper sense math. Okay, fairness is guaranteed in case of Sharp, but fairness is not guaranteed in case of Lime. Okay, now how Lime works, it actually picks up one data point, only explains one prediction. It makes a fair neighborhood, changes the input slightly a bit, and asks the model to get the prediction. And train a simple model like a linear or a small tree and explain how the and show the feature importance. Okay, so this is how the line works. Coming down with how Sharp works, suppose each we have an idea about game. Okay, so each features in a player in a game, right? It predicts the score. It try all of the features combination, which features, without features, everything it will be going. It sees the contribution difference and share the reward finally. It is totally based on Shapley's value. Okay, so this is about coming down about the idea that we have gone up with. Now coming down, let's have an idea about this SAP maths and the and line maths. Okay, Basically, as you know, so what is prediction? Prediction, as we have gone with the weights, the same calculation we are going down for lime. But when we are going down for sharp, we are going down for the fairness. We are going down for the fairness, right? So sharp value actually gives us the average contribution across all of the features combination. Okay, so that is what sharp is giving us. So there is some of the limitations related to line, that is different result in each run that we will be getting in case of lime. It depends on the random sampling and all not always reliable. That is lime. Okay. And coming down with sharp, sharp is of course a bit slower. The math is more and more complicated in some case, and there is a heavy computation. Okay. So if we are thinking about quick explanation, then Lime is the best tool. If we have to get a legal fairness, then Sharp is the best tool. About medical AI, Sharp would be the best tool in terms of explainability. About demo to kids, in that case, Lime would be the best tool. About auditing AI, in that case, Sharp would be the best tool. Okay. Lime is a local, not a global one, but Sharp is both local and global. Okay. And Lime is a fast guesser. Sharp is a fair accountant, not a fast guesser. Okay. So this is the idea about Sharp and Lime. Okay. So hopefully, guys, you have understood each one of it in details. If then also you have any question, any specific question, I'll be there to help you out to answer it. You have to note it down and keep practicing with the other stuff. Okay. So we will be having the projects all together after the sessions. Also, like after each module, we will be having the projects accordingly. So that will be explained to you accordingly. Okay. So till then, we will just wrap up this session today. So we'll meet again in another session. Thank you for just joining today's session. Bye, guys.